fifth graders, welcome back to Math Expressions with Miss Hasty. Today is lesson 6-4, okay? And we're going to be using rounding to determine reasonableness while we perform our word problems, okay? So the pages in our activity book that you need to be on is page 249 and 250. We're going to complete those together. And then we'll go over your 6-4 homework and remembering and send you on your way. Okay, so hopefully you are prepared and ready to go. Page 249, sorry. Alrighty, let's read our directions here. Write an equation, use it to solve the problem. Use rounding to show that your answer is reasonable. All right, so all together, 91,292 people live in Waterloo and Muscatine, two cities in Iowa. The population of Waterloo is 68,406 people. What is the population of Muscatine? Well, we know the total number and we know the population of Waterloo. So, yeah, there I go again. I gotta get my drawing tool on, sorry. Okay. So we know that there are 68,406 in Waterloo, but we do not know how many people are in Muscatine, so that is our unknowns. We'll call that N. But we do know there's a total of 91,292. All right, so to solve this problem, this is our situation equation, but our solution equation would be 91,292 minus, make sure you line it up. Oops. I'm a little shady today. I don't know what's going on. All right, 91,000, I did it again, 292 minus 68,406. Okay. Subtract those, and that is going to give you how many people live in Muscatine. Now, to check if your answer is reasonable, you take those numbers, let's say 91,292, and let's round that to a nice round 90,000. And 68,406, let's round that to 70,000. Okay, and I'm going to get 20,000. So my answer should be close to 20,000. And we like to know if something is reasonable to know if our answer makes sense. Okay? So number 2, Vernon spent $229.06 for groceries and paid for his purchase with 5 $50 bills. What amount of change should he have received? Well, we have to figure out how much he started with in the first place. So there are $50 bills and there's 5 of them. So you need to multiply that first. And what he spent on groceries was $229.06. Okay, so you have to get that unknown amount to see how much change he should have gotten. And if we were going to estimate this to see, so what is 50 times 5? Okay, that's 250. And then you're going to subtract that 229.06 to get your unknown amount, right? Now 250 is already a nice round number, so I don't need to always estimate and change my amount. I like that 250. It's nice and round already. But 229.06, how about I round that to 230 to make my life easy? So 250 minus 230 is 20. All right, so your answer that you get should be pretty close to $20. And then you know that it's reasonable. All right, moving along. Okay, new directions. Write an equation, solve the problem. Use estimation and mental math to show your answer is reasonable. Okay? Number 3, in a school gymnasium, 588 students were seated for an assembly in 21 equal rows. What number of students were seated in each row? So we know the total amount. We're going to divide that by how many rows, and that's going to get how many students, we'll label that S, were seated in each row. Okay? Now I want to check and see if my answer is reasonable or about what I should get. So my 588 here, I'm going to round that up to 600. And my 21, I'm going to round that to 20 to make my life easy. So 600 divided by 20 is 30. All right, so my answer should be pretty close to that when you solve it. And if it isn't, then you probably have to check and see if you did something wrong. Okay, number 4, to get ready for her first semester of school, Jana spent a total of $7.92 for 8 identical notebooks. What was the cost of each notebook? Okay, so we have cost of each notebook times 8 is $7.92. All right, that's our situation. We don't know the cost, but we know times 8, it equals $7.92. So how are we going to solve for that? Our solution equation then is your $7.92 divided by 8 is going to give you the cost. Okay, so now you have to solve that. And then we're going to look at, well, what would make sense? If I have this $7.92, I can round that to $8. And if I divide $8 by 8 notebooks, I get about $1 a piece. So that's estimating how close you should get when you figure out your answer. All right, let's turn the page and go to the second page, all right, which is 259. All right, use benchmark fractions to determine reasonableness. Remember, when we're dealing with fractions in benchmarks, if it's less than 1, then our benchmarks are 0, half, and 1. But if it's greater than 1 and we have whole numbers involved, then we're dealing with what is the closest whole number that it would round to. Okay, so let's look at number 5 here. A 5/8 inch thick paperback book is placed on top of a 15/16 inch thick paperback book. What is the total thickness of the books? Well, the first thing you're going to have to do, total thickness, we're adding them together. So you're going to have to add 5/8 and 15/16. And you need to get a common denominator to do that before you can add them. Okay? And then to estimate, when we're estimating that, so 5/8 and 15/16, 5/8 is pretty close to a half. Remember, our benchmarks, if it's either half, 0, half, or 1, how close are you? Okay, so 5/8 is close to a half, and 15/16, that's almost a whole. Okay, so a half plus a whole is 1 1/2. So when you get your answer for this problem here, it should be pretty close to 1 1/2. Okay? Number 6, a cabinet maker cut 7/16 inch off of a board that was 2 7/8 inches long. What is the new length of the board? Well, we know what the board was originally, and if he cut it off, that means he's subtracting. Okay, and then what is the new length of the board? Okay, we'll label that N for new length. All right, so you're going to get your answer there. But again, get common denominator for your 8 and 16. You have a whole number of 2. The second number doesn't have a whole number. So do your subtraction there. And then when we're going to estimate, here we have 2 7/8. Well, that's between 2 whole numbers. And the 2 whole numbers would be between 2 and 3. 7/8 is almost another whole. So we're going to say that 2 7/8 is very close to 3. And 7/16, well, 8/16 is half. So we're going to call that 3 minus a half. So if you have 3 minus 1/2, you have 2 1/2. So your answer when you solve this should be pretty close to 2 1/2 then, to show it's reasonable. Okay, the last activity one together. Write an equation, use it to solve the problem, use mental math to identify 2 whole numbers your numbers should be between, okay? So 4 runners completed in a 10-kilometer relay race. Each runner ran the same distance. What was the distance? Well, we know it is 10 that they ran all together, and there's 4 runners. So 10 divided by 4 is going to give you the distance, and this is going to be in kilometers, right? That each one of them ran. Well, you're going to do that math here. So if you take 10 divided by 4, all right, you're going to end up with 2.5. Okay, so I'm just going to walk through this one for you though. And then use mental math to identify two whole numbers your answer should be between. Well, 2.5 is between 2 and 3, right? It's between 2 and 3. Okay. All right. Now let's go ahead and look at your homework. Okay, let's see what you're going to be doing on there. 6-4 homework. All right. In a speed test, a computer took 12.4 seconds to complete one task and 37.8 seconds to complete a more difficult task. How much time was needed to complete both tasks? All right, that's going to be an addition problem there. So you're going to add those two together, but then you're also going to estimate, okay? Now, if you were going to estimate 37.8, what nice round number would you estimate that to? What would you round it to? It can be a nice whole number. And then you're also going to estimate 12.4. Round that one to a nice number that you can add together and make sure your answers are reasonable, okay? Number 2, to walk to school. Pablo first walks 1/2 kilometer to Tanya's house. Then Pablo and Tanya walk 3/5 kilometer to school. How far does Pablo walk to school? Okay, so you have a half. Oopsie. I don't know why that did that. Half plus 3/5. That's going to give you the total distance because he walked first a half to her house and then he walked 3/5 with Tanya to school. So you're going to get that answer. Get your common denominator, add those together. But then you're also going to round. Well, a half is already a half. I don't need to round that. So that can stay as an estimate of a half. 3/5 though, is that closer to 0, half, or 1? You decide that, okay? And then add those together and see if it's close to your estimate. Number 3, each Saturday morning, Andy works 4 hours, earns $34. At that rate, what does Andy earn for each hour he works? Well, we know the total. Okay, so let's do a situation equation here first. All right, he earns per hour. We don't know that, but he works 4 hours. I don't know why that shuts off once in a while, guys. Sorry about that. We'll fire her back up. Okay, and he works for 4 hours. Gotta draw again. I tell you, technical stuff. What are you gonna do, right? All right, times 4. Now it doesn't want to draw at all. All right, guys, I'm going to talk through this. So he works 4 hours, and we don't know how much he earns, but a total of $34. So you're going to take your $34 divided by 4, and that's going to give you how much he makes in an hour. Okay? I'm just going to plug this in. Maybe it's out of charge. All right, and then you're going to estimate that. Okay, so 34, you could round that a little. You could round that to 30, and your 4, maybe you round that to a nice round number that goes into 30 and see if your estimate is close to your final. And number 4, Yuri completed a race in 0.88 fewer seconds than Josie. Josie's time was 23.95 seconds. How long did it take Yuri to complete the race? So he completed it in fewer seconds than Josie. So your equation here is going to be 23.95, subtract the 0.88 for Yuri, and then that's going to give you how much time it took him to complete it. And then estimating, round that 23.95, round your 0.88 to nice round numbers, subtract it, and see how close you are. All right, we're going to try this again. Let's go to the remembering side, go through a few of those, make sure we remember what we're doing. Okay, so 41 times 77. You're going to have to do your exact answer over here, but here you're going to estimate and see how close you are. So 41, that rounds to a nice 40. 77, I would probably round it to 80. 40 times 80, get your answer. and then see if when you get your exact answer, if they are close. Okay, so that is 1 through 3. 4, 5, and 6 are dividing. Make sure that you check your division with multiplication so that you know your answer is correct. Number 7, write a word problem for the equation. Draw a model to show the situation. All right, so 5 6 times something equals 26. Now, if you solve that first, you're going to get a 4, right? So 5 times 4 is 20, and 6 times 1 is 6. And then you're going to write a word problem. Well, this is very similar to the first word problem in our activity from yesterday, like a recipe that uses 5 6 cup, and they multiplied it times 4 servings. Okay, so that would be a really good one to use there. Okay, and here we are at our last problem. Stretch your thinking. Kaylee has 2 3/8 yards of fabric. She cuts and uses 1 1/16 yards from the fabric. She estimates that less than 1 yard of fabric is left over. So first you're going to solve the problem. She starts with 2 3/8. Why am I not writing? Okay, it's not writing. Starts with 2 3/8 yards, and she uses 1 1/16 yards. So that's a subtraction problem. Okay, so then you're going to get your answer. How much does she have left? And then estimate, is that close to a yard? Is that correct? So you need to estimate 2 3/8. What whole number would that be closest to? Because it is a whole number there. So 2 or 3, and then 1 1/16. What would that be closest to? Okay, so explain how you know if that estimate is reasonable or not. All right, you have everything you need to complete 6-4. So good luck with that, and we'll check your homework and remembering at the end of the day. Have a great afternoon. See you next time.